day everyone and welcome to these lectures on physico-chemical processes for wastewater treatment. In the previous lecture we started with one of the unit operations which is called as adsorption and which is most commonly used in all the water treatment and wastewater treatment processes. It may be used in the initial stages and it may be used in the tertiary stages in the wastewater treatment. So, both are possible. Now, is continuing with the previous lectures. In the previous lectures we studied that there are three important properties which are the most important characteristics which are desirable in any adsorbent. So, these properties included the surface area or pore surface area, which was the first property. Second was the what is the pore size of the average pore size. So, that is very important property. And the third property which was there, what are the functional groups which are present on the surface of the adsorbents. So, this was there. Now, the pore surface area and pore size, the two properties tell us that okay, there are two things. If suppose any adsorbent is there, so that adsorbent may be having different pores the way it is shown here in this slide. So, its outer surface area will be different and suppose the any spherical particle is there, suppose this adsorbent is spherical in nature. So, its outer surface area is 4 pi r square. So, that we know very well where r is the radius. So, this is known, but remember in the previous lecture we studied the surface area is in the range of 4 pi like 1200 or 1000 meter square per gram or more. So, for activated carbon, so commercial activated carbon. So, surface area may be more than that. So, if we consider 4 pi r square, the external surface area will always be less. So, this is there. So, 4 into 22.7 and suppose the diameter of the particle is very less. So, depending upon that suppose 1 millimeter size is there also. So, for 1 millimeter 1 into 10 raised to minus 3 square and in 1 gram suppose we may have tentatively some number of adsorbents. So, in 1 gram number of adsorbents may be selected number of particles of the adsorbent that may be there. So, if you multiply this external surface area will be much lower than the pore surface area which is there as well. So, that means what we require is that the adsorbent should be highly porous with lot of pores in which the adsorbent or the adsorbate may move. So, what we desire is that the adsorbate should be able to move inside these pores and this should be highly porous. So, that the surface area, this surface area which is there in the pore, that is available for adsorption to occur, where the molecule adsorbate molecule may come, they may like get adsorbed here. So, we always require highly porous adsorbent. Some of the pores may be open, some of the pores may be closed. So, there are different types of pores which are possible. So, that we will study more, but here we can see here open pores are those which are accessible to the adsorbate, whereas the closed are those which are inaccessible. So, open pores can be interconnected, they may have a passing connection also, they may be totally blocked also, they may be dead end. So, like here you can see interconnected pores. So, this pores is there, suppose this is open. So, this is also interconnected. So, this interconnectivity may be there. This is passing pores, it is all throughout the adsorbent itself. So, this is like a passing pore which is there. This pore is dead end pore because it closes at one end. So, there are different types of pores possible. Now, these pores can also be classified further like cylindrical pores etc. So, we will discuss those also in later on. So, this is so important thing is that what is the average pore size which is there. So, can any adsorbent, suppose the adsorbent molecule is this. So, this adsorbent molecule, despite this adsorbent having lot of pores, this cannot go inside any of the pores. So, that means this adsorbent will be having very less capacity with respect to adsorption of this particular adsorbate, and this adsorbate which may not get inside these adsorbents. So, it may maximum get connected at the surface only. So, its adsorption capacity will be very less. So, this is there. Going further, there are many steps which occur during the movement of this adsorbate inside this pores until unless they get adsorbed. So, what are those steps? So, for understanding this, we must again go back and try to understand the in the previous slide, like in the previous lecture we discussed, suppose there is a, this is a beaker is there, and beaker is having this solution which contains the adsorbate which has to be adsorbed. Now, it contains an adsorbent particle, and this adsorbent particle is there, and this is some molecule which is to be adsorbed. So, there are different sections of movement of this particular adsorbent adsorbate inside this adsorbent. So, these are called as adsorption steps, are the mechanism how which this adsorbate is moving inside this adsorbent and getting adsorbed. So, this is there. So, the first phase is transport of adsorbate from the bulk of the solution to the exterior film surrounding the adsorbent particle. Now, whenever there is adsorbent particle in the liquid phase, it will always be surrounded by some liquid film which will always move along with this adsorbent wherever it moves. So, that is there. So, liquid film, stagnant liquid film will always be there around the adsorbent molecule. So, that means the adsorbate has to first move to the exterior film surrounding the adsorbent particle. So, this is the first step. Now, second step is that movement of adsorbate across the external liquid film to the external surface site on the adsorbate particle. So, that means the adsorbate has to move across the film. So, this is called as film diffusion, and so and first phase it is called as also called as bulk diffusion also. So, this is like bulk diffusion. Now, in the third stage, migration will occur within the pores of the adsorbent. So, suppose this is the film, you can see here the film is there. Now, the adsorbent will move inside the pores, that means we can see here the adsorbent has moved up to the surface. So, it has come inside the surface, but it has not moved inside the pores. Now, it will move inside the pores. So, migration of adsorbate within the pores of the adsorbent by intraparticle diffusion, it is also called as pore diffusion, and pore diffusion may also be further be classified, like whether it is moving from bigger size pores or smaller size pores. So, that is also possible. Now, when the diffusion will occur, after diffusion occurring, then the adsorbate will get adsorbed at some surface site. So, suppose surface site is here or here also. So, first molecule will come and get adsorbed here. So, this is the last step or fourth step, adsorption of adsorbate at the internal surface site. So, this is the step. Now, going further, now if these four steps are there, suppose, so this is like a adsorbate moving from the bulk of the solution and going inside this particle, adsorbent particle. Now, we want all these steps to be as quick as possible, because overall contact time the time which will be there for adsorption to occur will be dependent whether how fast all these steps are. So, for doing this we need to fasten all these processes, so that we can identify the rate controlling step or the slowest step, and we always try to see that the slowest step also becomes faster. So, that the overall reduction in the adsorption time occur. So, if this is possible, we can have a packed bed which can treat more amount of material within the same time. So, all those conditions we always want the kinetics to be faster or the adsorption process to occur very quick. So, that means we have to see that these steps which are there, bulk diffusion, film diffusion, pore diffusion, and ultimately the adsorption occurs very quickly. So, for doing this, now suppose the in a rapidly stirred well mixed batch system, suppose this is only a batch stirrer is there. So, under that condition, since it is very well mixed, the mass transport from the bulk solution to the external surface film of the adsorbent will be very fast. That means, the bulk solution is always good if we are rapidly stirring the solution. So, that problem is not there. Now, for the second case, the resistance for the transport of the adsorbate from the bulk of the solution to the exterior film surrounding the adsorbent may be small if it is very fast, and that can be neglected. So, bulk diffusion is not an issue if we have a rapidly stirred system is there. Now, the adsorption of the adsorbate at the surface site, that means the fourth step, this step is also very quick. Generally it is very quick and it has negligible resistance as in comparison to steps 2 and 3. So, first step bulk diffusion and the fourth step adsorption, they are always very quick. So, there is not much of an issue. The issue generally lie with film diffusion or the pore diffusion. So, that means they will be generally the slowest step. Now, if we have a rapidly mixed batch system, the film diffusion will also be, the film will be lesser in its thickness will be less. So, that means the molecule has to only diffuse a very small distance. So, that means the film diffusion will also be faster as compared to the pore diffusion. So, under that condition, the pore diffusion may be the rate controlling step. So, either second step or third step, they may be rate controlling. Now, in most cases steps second and third, which are like sorption phenomena, they control the sorption phenomena and they are like film diffusion and pore diffusion. So, there are different possibilities which are there with respect to these two diffusions. So, in the case when the external transport may be faster, that means the film diffusion is faster as compared to the pore diffusion. Second case, the external transport is lower as compared to internal transport. So, that is possible. So, pore diffusion may be the rate controlling step, and in some cases both are equally similar to the condition. So, it is possible. So, here the rate in the first step it is controlled by film diffusion. Okay, here external transport is fast, so it is pore diffusion limited. Okay, here it is film diffusion limited, because here the internal transport is very quick and external transport is slow. So, it is opposite way it is written, it is first and second and first it should be written. Okay. In the case third, the transport of ions to the boundary layer may not be possible at a significant rate, and thereby leading to the formation of a liquid film with a concentration gradient surrounding the adsorbent particle. So, it is possible. So, we will have to see and examine and properly optimize these conditions, so that at least if you have proper selection of adsorbent and we have conditions which are good enough, we can avoid these slower steps also or minimize the resistances which are there. So, these resistances we need to determine and we need to understand, so that we can properly select an adsorbent and our overall treatment process will become faster because of that. So, this is there. Now, in the fourth step which occurs where the adsorption occurs, this adsorption of adsorbate at the internal surface site, that may occur by two mechanisms. One is that there is some chemical bonding occurring, that the surface site contains some functional groups which is polar, the adsorbate is also polar and they are of opposite nature. So, they will attract each other and chemical bonding may occur. Similarly, if it is not there, both are non-polar. So, under that condition some formation or some physical attraction may occur and that will be governed by van der Waals forces of attraction. So, this is possible. So, under that condition also we have van der Waals forces of attraction. So, chemisorption and physisorption are the actual terms which are used for finding out the last step by which the attraction may occur. So, in the physical adsorption, which is also called as physisorption or van der Waals adsorption, this is one of the method of adsorption in the fourth step. Now, similarly chemisorption, chemical adsorption or activated adsorption, this is also possible. Now, both have different mechanisms and different features which are compared here. Now, the van der Waals force of attraction is a weaker force, that means the force of attraction between adsorbent and the adsorbate is van der Waals force and it is weaker in the physisorption which is called or physical adsorption. If the force is weaker, so at least there is a possibility that adsorption may occur, but suppose later on when all the adsorbent has been totally spent, that means there is no further capacity. So, we can take out the adsorbent and we can desorb the adsorbate out of the adsorbent. So, it is possible to regenerate the adsorbent more easily in the physisorption as compared to in the chemisorption, because in the chemisorption we have the force of attraction between the adsorbent and the adsorbate by chemical forces. So, that means some bonding may occur. So, these bonding may be strong. So, that means if we have to regenerate the adsorbent, it is not possible as easy it is in the physical adsorption. So, this is one difference. Second, there is another difference, that generally physisorption occurs at low temperature, whereas chemisorption occurs at high temperature. So, this is possible. So, this is general, it may be possible vice versa also, but this is the general difference which is there. Almost all gases show physisorption at low temperature and it is non-specific in nature. Non-specific in nature means that any type of gas it may get physically attracted and get adsorbed, whereas in the chemisorption some specific nature of adsorption may occur, because the gas may be inherently acidic in nature and the adsorbent may be basic in nature. So, under those conditions the chemisorption may occur, and but it will be not non-specific. Why this is so? Because it will only adsorb those gases which are acidic, because the adsorbent itself is basic in nature. So, it will not adsorb anything which is basic. So, that means the adsorption will be only highly specific in nature. So, this is possible. Now, enthalpy of adsorption for the gas phase separation is like for physisorption it is lower, 20 to 40 kilojoule per mole. It is much higher for chemisorption, it is given here. Now, the physisorption attains very quick, very rapid and on changing temperature and pressure of the system. So, this is faster, as physisorption is faster as compared to chemisorption which is slower. This is reversible in nature, already showed, because it is weak force of attraction. So, we can easily apply some other force or temperature to dissolve the gases or the any pollutant out of that. So, it is reversible in nature, and this is not reversible. A chemisorption is not reversible because chemical bonding has occurred. So, suppose we have to take out, so it is possible that we may have to use some solution or something which may have a stronger bonding towards the adsorbate as compared to the adsorbent itself. So, that means suppose this is the adsorbent surface, and now this adsorbate has come and there is a chemical bond. Now, suppose now what we want to take out this. So, that means there should be another molecule which should come and it should have more stronger bond than this bond, then only this bond can be broken. Otherwise, this irreversibility will not cannot be changed, and it will always, this will be always be attracted towards the surface. So, this is there, and because of that these things, the energy of activation involved in the physisorption is low and it is very high in the case of chemisorption. Now, since and this is the last difference which is there, it is very important. Since the physical nature of adsorption is there, it is possible to have multi molecular layers also, because suppose the surface is there. So, this is the surface and one molecule will come and they will bond like this. So, this physical adsorption has occurred. Now, if suppose the surface gets saturated, so another layer may get formed because it is only physical nature of adsorption. So, bonding may occur between the adsorbate also. So, multiple layers are possible. This is not possible in the case of chemisorption because some bond formation has happened between the adsorbent and the adsorbate. So, and that bond formation is not possible within the adsorbate. Now, this bond is not possible to be formed within the adsorbate. So, that is why in chemisorption only single layer adsorption may occur. If any multi-layer formation is occurring, so that will be only physical in nature. So, the other layers which may get formed, that will be more physical adsorption after one layer which has been formed because of the chemisorption. So, these are the various differences which are there between different types of attraction or the forces which may be there while the adsorbate gets adsorbed on the surface of the adsorbent. So, we can see here. So, the diffusion is occurring in the first step, then here migration into the pores is happening, and then ultimately monolayer buildup is here. This is the monolayer buildup which has occurred. So, monolayer is more possible in the case of chemisorption and multilayer is more possible in the case of physical adsorption or physisorption. Now, there are various factors which control the adsorption process. So, what are those? Some of these things we will try to discuss today. So, already we have discussed one of the important parameters with respect to. Now, the factors which may control the adsorption, they may be classified into three categories in a way. One is like dependent upon the adsorbent. So, this is possible. The property of the adsorbent controls the adsorption phenomena. So, adsorbent properties become very important, or nature of the adsorbent, that becomes very important. Second thing is the properties of adsorbate, that may also be crucial in deciding whether the adsorption may occur or may not occur. And third property is the solution itself, whether it is acidic, basic, or whether it is gas phase, liquid phase, etc. So, all these factors may affect within the solution or within the treatment. Operating conditions may also become very important with respect to controlling the adsorption. it is possible to change the operating parameters like temperature, and by doing this at one temperature there is, it is possible that there is no adsorption occurring, but higher temperature or lower temperature adsorption may occur significantly. So, we can always manipulate with the operating conditions later on, but first and foremost adsorbent properties and the nature of the adsorbent and the solution, they become very important. Now, we will start with the nature of the adsorbent. Now, already we have studied, discussed few of the properties with respect to nature of adsorbent, and the physico-chemical nature of the adsorbent is very important, and adsorbents, they may differ in the specific surface area and affinity for the adsorbent. Now, specific surface area may change. Many commercial adsorbents may have very high surface area, like metal organic frameworks may have more than 5000 meter square per gram, up to 7-8,000 also they have gone. Now, there are some simple charcoal that may be having only surface area of 100 meter square per gram, but that will be available very cheaply. So, this is possible. Now, affinity may also be different for different types of adsorbents. Already we have discussed whether adsorbent is polar, non-polar, whether it is acidic or basic. So, all these properties affect its affinity towards the adsorbent. So, adsorbent's affinity or adsorbent's property also become very important. Now, adsorption capacity that we have earlier discussed is directly proportional to the exposed surface area. So, that means for the non-porous adsorbent, suppose it has very less surface area, around 10 meter square per gram. So, under that condition, suppose we have two adsorbents, both are having same capacity or they have very less capacity. So, that will depend upon the for non-porous adsorption, the absorption capacity depends upon the particle diameter. So, if there is two balls which are there, so smaller size balls will be having higher surface area, and we can keep more number of balls within a certain volume. So, that is possible. So, we have more external surface area. So, for non-porous adsorption, the adsorption capacity is inversely proportional to particle diameter. Now, for porous materials, the material is highly porous, it has very high surface area, etc. Under that condition, it will be independent of the particle size. So, the adsorption capacity will not depend upon the particle size. Particle size will still be important with respect to pressure drop and other things. However, for porous substances, the particle size affects the rate of adsorption, it is possible. So, this is there. So, that is different thing, that adsorption capacity we may have different. For substances like granular activated carbon, the breaking of large particles to form smaller ones open up the various sealed pores or channels, making more surface accessible to the adsorbent. There is another very important property which was highlighted in previous slide is pore size. So, there are classification of pore sizes. So, as per International Union of Pure and Applied Chemistry IUPAC, there are three types of pores which are classified. So, one is like micropores which are having diameter less than 20 angstrom. So, this is there, that means 2 nanometer. So, sometimes in the nanometer is also written. Similarly, mesopores have diameter in the range of 20 angstrom to 500 angstrom, and micropores are those pores which are having diameter more than 500 angstrom. Now, micropores can also be further divided into ultra micropores and super micropores. So, ultra micropores are having diameter less than 7 angstrom and super micropores have diameter between 7 to 20 angstrom. So, it is possible. Now, for gas phase separation, micropores are important because if more micropores are there within the same surface area, the surface more of the pores can be utilized for gas phase separation. But for liquid phase adsorption, for water or wastewater treatment, mesopores are very important for water treatment. So, we always look for adsorbents which have more mesopores. So, this is very important. So, this is more important for water treatment as compared to any other thing. So, mesopores is the pores which are we are looking for water or wastewater treatment, because generally the pollutants which are present in the liquid stream are always of diameter bigger size as compared to 2 nanometer. So, we have mesoporous silica, activated carbons, all these things can be used more because they have more surface pore size which is between 2 nanometer to 50 nanometer or 20 angstrom to 500 angstrom, which are listed here. Now, micropores which are used for gas phase separation, generally we always see that geolites, metal organic framework, activated carbons also can be used, because activated carbon may have micropores also. For mesopores is more true for water treatment or wastewater treatment. So, we always look for mesoporic adsorbents which may have pores more in the mesoporous range for water treatment. So, this is used. Micropores are not that much considered, because if any material is having more micropores, it may be underutilized. So, micropores are only bigger size pores where the initial transport of the adsorbate will occur. So, this is there. Now, there are different possibilities of shapes of pores also. Already we discussed that there is a possibility of cylindrical pores, like here you can see we may consider this to be a cylindrical pore. So, this is possible, cylindrical pores are possible. There are many other types of pores are also possible, like slit shaped. So, this is possible. So, it may be having slit shaped pores, it may be having conical pores. So, initially the pore size is bigger, but it is becoming smaller, and that length in which it is becoming smaller is very small. So, that will fall into the category of conical pores. There is a possibility of ink bottle type of pores. So, that means the inside the pore is very big, but the path which is there for moving inside is very small. So, that will come under the category of ink bottle pores. So, this is possible. Similarly, in between interstices may be there. So, these type of pore shapes are also possible. So, we always try to analyze all these types of pores etc., and we try to analyze all these things, and we try to discuss the we can determine the pore shapes, pore surface area, and what is the pore size through a method which is called as liquid phase nitrogen adsorption. So, what we do is that we adsorb the liquid at very low temperature, we adsorb the nitrogen at very low temperature, and that temperature is less than minus 193 Kelvin. So, sorry, less than minus 193 degree centigrade. So, under those conditions we try to find out that how much liquid nitrogen has been adsorbed, and through the different shapes of the adsorption isotherm which are there, different types of classification of pores, pore diameter, pore surface area, everything can be determined. So, we will discuss all these things further in later classes, and we will understand the other factors also which occur which affect the adsorption process along with the adsorbent properties. So, we will discuss all those properties in the next lecture and what are the different parameters which affect the adsorption process. Thank you very much.